Hey AP Stats, it's Mr. Luneski here. Today we are talking about chi-squared tests of homogeneity and tests of independence. So we talked about goodness of fit tests on the previous video. So this one we're still looking at a chi-squared test, but for what are the observed matrix, the expected matrix. We have the observed values in matrix A. We're going to put the expected values in matrix B. The nice thing is the calculator does all the work for us, so we don't actually have to do anything. Just hit calculate. The reason that I say we do box 2 first, or I'm sorry, box 3 first, is because now we have all of our output data for our mechanics. We have our test statistic, we have our p-value, and we have our degree of freedom. If you take a look at the p-value, very, very low here. So I kind of just went ahead and wrote, and just wrote those values down. So here's our chi-squared, our p-value is approximately 0, degree of freedom is 2. Degree of freedom, when it is a contingency table, is the number of rows minus 1 times the number of columns minus 1. So jotting that data down. So now that we have that data, we can say, yeah, all the expected values are above 5. Conditions are met, we'll run a chi-squared test of homogeneity. So here, p-value is less than 0, so we reject the null. That means that there is statistically significant evidence to support the distribution of income is not the same for men and women. Alright, so that's a test of homogeneity. If we are looking at a test of independence, it's a little bit different. Let me just zoom in here. So for a test of independence, that is whenever we are going to be looking at whether or not there is an association between the two variables. And that's kind of what we're going to be looking for in terms of our